of Keysight, what was previously the Agilent Technologies. So I've been an employee of Keysight for almost 6 years now and have been involved in marketing throughout my time here. Prior to Thermal Imager and other Keysight handheld tools, I was actually managing the USB modular products and some basic bench digital multimeters. As a product manager, I am constantly engaged with distributors and customers, sharing my knowledge on the product as well as learning from them on their actual applications. So I will be sharing with you some of the applications I will be sharing with you in a few minutes. So I also work very closely with Siyong, who happens to be our question manager here today. Siyong has more than 14 years of experience in test and measurement, and since joining Agilent in year 2000, he has held different roles ranging from product engineer, test engineer, and MPI engineer within the order fulfillment organization, and to design validation and as well as the design validation engineer within the R&D organization. So Siyong is currently a product planner for industrial thermal imagers within the marketing organization. And he interacts with customers and distributors and has broad knowledge on thermography products and applications. So if you have any question at all during the presentation, please feel free to ask in the chat. So without further ado, let's proceed to look at the agenda for today. So here is the agenda lineup for today. We will first take a look at why we perform temperature measurement and why thermography is a popular temperature measurement instrument. Next, we will look at applications where thermal imagers would be useful. We will take a deeper look into industrial applications as well as electronics and PCB characterization and troubleshooting application. For beginner or new user of thermal imager, I will also be sharing with you some tips and tricks on how you can capture IR images correctly. And last but not least, I would like to introduce Keysight's TrueIR thermal imager that was launched back in June this year. Okay, so moving forward, did you know that temperature is one of the most widely measured parameter of a physical property? Many of our daily activities evolve around temperature. And for example, chefs will check the temperature of cooked food to make sure that they are safe to consume. And well, for doctors, they will check their body temperature to know their patient's health conditions. So all in all, taking temperature reading will tell us the condition of an object, whether it will have normal or abnormal performance. So there are actually two main techniques of temperature measurement. The traditional way would be to perform contact measurement, where one utilizes thermometer or thermocouple. A more advanced technique would be to use non-contact measurement tools like infrared thermometer or thermal imager. So why do we use the thermal imager? Why thermography? Why don't we use thermocouple? Well, in general, the advantages of infrared thermography are non-contact measurement, where we can measure from a distance while the system is running. Secondly, since the thermal imager only measures IR energy emitted from an object, it will not affect the target object in any way. Thirdly, we can observe the temperature patterns and distributions, and this is an advantage over the use of thermocouples, which determine temperature only at specific spots. So this also actually reduces the risk of overlooking problems that might occur in other areas within the equipment or machine. We can also capture the data and IR images for reporting and filing purposes. And last but not least, with technology advancement, thermal images are getting smaller and smaller, hence making them very portable and very easy to carry around. So as you can see on the screen, those highlighted in greens are the impact of using the infrared thermography. Next, so what are its limitations? First, the thermal images are complex to operate and interpret results for most users. A thermographer will also need to be trained and certified before he or she can use it correctly, especially for quantitative analysis. Once the IR image is obtained, a specialist is usually needed to interpret and conclude findings or results. A thermal imager can take an IR image or object that is in line of sight only, and it does not see through opaque materials. Okay, and next, the thermographer needs to understand how parameters such as emissivity, reflectivity, and even the field of view can affect the final IR image. So, making a decision whether or not infrared thermography is suitable, you need to run through these advantages and limitations against your applications. And chances are the advantages will outweigh the limitations. Many are actually realizing the potential of an IR thermal camera in helping them to identify issues and solving the problems. Okay, so next let's take a look at how a thermal imager would be used in an industrial application. As you can see, here are some IR and visible images of electrical systems in a typical manufacturing plant. In fact, what you will see is the same in any building like hotels, offices, and so on. So IR thermography inspection is typically run at a specific time interval just to make sure that the electrical switchboard, the motors, and its corresponding controllers, transformers, and so on is working correctly. So some will actually describe this as performing a predictive maintenance. When at any given time a hotspot is detected, it might indicate that the system is about to break down. IR thermal inspection gives a good qualitative result, and by qualitative result, we will often compare them to the adjacent system, circuits, or terminals. So no exact temperature measurement is necessary in this case for qualitative. Okay, so looking at these two IR images, we can see hotspots on the terminals and wires because they appear hotter when compared to the adjacent terminals. Hotspots in electrical systems translates to potential problems. So here is a list of potential causes of electrical hotspots for your reference. For example, we could have a bad connection that is caused by loose wire, triggering induced resistive heating, or a broken copper strand in wire, which might not be visible to naked eye, but with the thermal imager, you will be able to see hotspots due to the increase in resistance. So all in all, IR thermography inspection of electrical system has been gaining popularity as an effective predictive maintenance practice for facilities and manufacturing plants. So next, let's look at another application that is gaining popularity in R&D, PCB Design Characterization and Troubleshooting. So if you're an R&D electronics engineer having completed your first prototype, it seems like everything works as designed. However, a temperature characterization of your design is necessary to ensure that its components do not get overheated through normal use. So usually with your nodes, you can theoretically derive where the most power is dissipated and identify the potential problem areas, but a flaw in the design where power is being consumed at an unexpected rate might go undetected. So with a thermal imager, you can get faster and better insight into circuit board's overall temperature distribution. You can also capture images at a specific time interval to monitor the temperature changes during power up or over specific time period. Shown here in this slide is actually some IR images of a PCA under test. Okay, as you can see, there are hotspots around the PCA. Okay, so these are some of the applications, other applications using a thermal imager. We have the predictive maintenance, building inspection, and under others are, for example, like the one I mentioned earlier, the electronics R&D, and some of the more interesting applications are like the fever detection at airport. We also have research in breast cancer. So those are the few emerging applications. Okay, but for some examples for electrical and mechanical inspection, for example, crack in refractory or water tank level and accumulations monitoring, as well as temperature distribution of paper mill. For building maintenance, some of the applications are HVAC system inspection or floor heating system checks. Okay, so this is just to give you some examples of how the thermal imagers can be used. So moving on, next is some of the tips and tricks that you can use with the thermal imager. So the number one tip that I'm going to share with you involves the parameter emissivity. Emissivity is the radiation of energy generated from the surface of target objects or materials. So the higher the emissivity of an object, the more accurate the temperature measurement will be, provided that these are set correctly. So many a time when a thermographer goes out for a field job, they might encounter certain objects where they are not familiar with the material. So the tip is usually to, so this tip is actually useful when this situation occurs. So how do you perform temperature measurement of an object with an unknown emissivity? What we need is to always have black body tape or electrical tape that can withstand harsh conditions. This tape will generally have a high emissivity of 0.95 to 0.98. So here are the steps to getting the temperature measurement. First, you need to clean the surface of the targeted object to remove any foreign materials. Step 2, apply the black body paint or black body tape with known emissivity. Thirdly, allow some time for the black body paint or tape to equalize its temperature. And then you can perform the reflected temperature calibration and set the known emissivity value of the black body paint or tape on your thermal imager. Okay, then go ahead to measure the temperature of the area with the black body paint or tape. Then measure the temperature of the object with no black body paint or tape, and then change the emissivity value so that the temperature matches that of the temperature of the spot and the black body paint or tape. Okay, so with that, you will be able to, get the right temperature measurement of the object with unknown emissivity. So the second tip that I'm going to share with you is actually a real example that our support engineer received regarding temperature measurement. So we do have customers who are using the thermal imager together with Thermocouple for temperature measurement, such as for temperature characterization. Thermal imager can be used to identify potential problem areas, like what I've mentioned earlier, while the Thermocouple can be placed in several locations at the problem areas for further design and temperature characterization. So, however, for this user, they are getting different temperature readings from the thermal imager and Thermocouple with 3 different DMMs. So why is there a big difference in temperature reading using the Thermocouple compared to thermal imager? So the one possible cause could be the Thermocouples generally have rounded shaped head, so users need to ensure that there is proper contact to the dart. And if the user decides to use a tape to ensure that it does not cover the Thermocouple's contact point to the dart, as the trapped heat might cause errors in the temperature measurement. So what's the temperature of the dart measured using the Thermocouple with the DMM and the thermal imager performed at the same time? One of the possible causes is that the dart might not have consistent temperature reading across its surface. So or the surrounding environment, like the reflected temperature, might also contribute to the error in the measurement using thermal imager. Okay. And other possible causes might be dirty surface on the dart, because dust has higher emissivity value and may contribute to error in temperature reading. Another possible cause would be wrong emissivity value of black body tape being used. User can assume the emissivity value, but it is recommended to get the correct value from the manufacturer, because setting the wrong emissivity may contribute to an error in the temperature measurement. And lastly, the distance where the temperature is measured using the thermal imager. This might actually cause some difference in the reading, because thermal imagers generally have specifications that states its accuracy with distance. So check out the specifications of the thermal imager that you're using to make sure that it is well within its accuracy. So here is the recommendation or solution to cater to the possible inconsistency of surface temperature. So when you're using a thermal imager, make sure to use the box temperature measurement to get at least an average temperature measurement of an area rather than a specific spot, because like I mentioned earlier, the dart might have inconsistent surface temperature. So but for the thermocouple, take thermocouple measurement at 5 single points as indicated in blue in the image to obtain an average temperature measurement. So with this, you will probably get a very close temperature measurement with the thermal imager and the thermocouple. Okay, next, I would like to introduce our newly launched thermal imager from Keysight Technologies. So this is the TrueIR thermal imager, the U5855A TrueIR thermal imager. Here are some of the key specifications that you might be interested in. First, it has the resolution, the detector resolution of 160 by 120 pixels, which can be quadrupled to 320 by 240 pixels through the fine resolution capability. Next, it has the sensitivity, thermal sensitivity of 0.07 degrees Celsius at 30 degrees Celsius. It has the accuracy of plus minus 2 degrees Celsius or plus minus 2%. So with this TrueIR thermal imager, you can definitely see more, and here is why. Firstly, you can get more details when you put together its quadrupled resolution and 4 times digital zoom capability to take an IR image of faraway objects. However, it can also take images as close as 10 centimeters away, just like something like a macro mode. Secondly, you can also capture more images with its light and evenly distributed weights, as it does not cause fatigue risk. And furthermore, with the use of an SD card, you can take as many images as your SD card can support, which is up to 32 gigabytes. Also, with the TrueIR thermal imager, you can capture temperature over time through the image logging capability and many options with in-camera measurement tools. And through its free downloadable software, the TrueIR analysis and reporting tool, you can generate reports quickly with the available templates. So all these capabilities for less than what you'd pay for a typical thermal imager with a resolution of 320 by 240 pixels. So let's take a look at how fine resolution works. So as I mentioned earlier on, the fine resolution enhances the resolution by 4 times, meaning you can see 4 times more details. And it also gives you 1.5 times better instantaneous field of view, and this is achieved using complex algorithm on a lower resolution detector. Fine resolution involves several processors that are designed to handle different tasks. Multi-frame acquisition involves the continuous capture of multiple IR images of images of the same scene. It also assumes that each of these frames will be slightly shifted due to the natural hand movement of the person operating the imager. Superpositioning is the next process to identify a set of common feature points on each of the frames and then positioning and aligning them accordingly to form a higher resolution image. And in the last process, in reconstruction, final touches are made to ensure a clear and sharp image is produced, a thermal image with 4 times more effective resolution. So with fine resolution capability, you will get the benefits of higher resolution without significant increase in cost. And here is the comparison of the TrueIR thermal imager to a competitive thermal imager with 160 by 120 pixels and 320 by 240 pixels detector resolution respectively. So as you can see, with fine resolution on the left, you will get the 320 by 240 pixels of radiometric JPEG images that are clearer and sharper. And together with its 4 times digital zoom, we can magnify faraway objects to reveal even finer details. And comparing the TrueIR image on the left to the competitors' similarly priced 160 by 120 pixel resolution radiometric JPEG, which is on the top right corner, you can see the very jagged lines in the IR image on the top right. Now compare the image on the lower right with Keysight's TrueIR image on the left. The image on the lower right is from a competitor's model with 320 by 240 pixel resolution and at a much higher price point. So you can see that the lower cost TrueIR image compares very favorably to the higher cost 320 by 240 image. So this slide proves that the fine resolution really enhances and sharpens the thermal images and is comparable to the thermal images that are generated from a higher resolution and higher cost IR thermal camera. So let's move on to the current promotion that is running for the thermal imager. This promotion is running all the way through May 31st, 2015. Anyone who purchased a unit of the TrueIR thermal imager will be eligible to receive a 2-year extra warranty to a total of 5 years at no extra cost, meaning we will get the general 3 years warranty, and with the registration, it will top up to become 5 years. And all these at no extra cost. All you need to do is to register the unit with the following link at www.keysight.com/find/HH_5warranty. So take advantage of this offer. Register your unit all the way through May 31st, 2015 to get your extended warranty for free. Okay, so next we've come to the question and answer session. So I'll pass over to you, Sabrina.
I'm here now. There are no questions from the attendees. Have you any questions? Tell us in the question and answer chat. Here's what is the price? Herr Dreyer, I answer to you. You can look at the Conrad page, conrad.biz. There's a price for you. Another questions? Not other questions. If you have any questions, you can tell me an email. I will give it to Janet and she can answer and I can tell it to you if it is okay. Now I want to tell you to come to Electronica at the Conrad booth. you can get free tickets from Konrad. I will show you the URL to get free tickets. One moment, please. Can you see my page, Janet?
I can see.
Okay. The URL is electronica.konrad.com, and here you can see you can get free tickets here on the button, and then you can get it. Now I look if we have another question. Okay. There's answered by Shansi. Now other questions I see. Janet, we are at the end now. I want to thank you. Have you to say something to the customer?
Yeah, thanks for attending the webinar today. And if you have any questions at all after this, do feel free to, maybe email us or Sabrina, and she will pass it along. Thank you.
Okay, thank you. Bye.